I've been learning about cache for a while now, and I've been going deep into the fundamentals. So I decided to build my own in-memory cache, and this is what it looks like. So it is in two parts. We have the cache, and then we have the API where I make use of the cache. So let's take a look at what I have in my cache. And in my cache, I'm making use of a class, and I declare this private store, which is going to be a single source of truth for everything I'm going to be storing in the cache. And then I have this in my constructor, and this is the store. And the store is making use of a map, which is very good for what I'm using it for. And in my cache, I have a method for setting. So this is basically like performing CRUD in the cache, because cache is like a memory where we can store and then we can also retrieve stuff. So now the set basically takes in the key, the value, and then we have the TTL, which is time to live in milliseconds. So this is basically like the lifespan of whatever we are storing in the cache. And once the time has passed the current date, it basically expires. So that's what TTL means. And then the map has a set method that we can basically use to add the new key value into the new map. So that is what is going on here. And this is how the store is going to be updated. And to retrieve a value from the cache, I have this get method that only takes in a key. This works like Redis as well, whereby you provide a key and then you get the value back. And what is happening here is basically checking if there's an entry for this key in the store. So if it is not found, we return null. But if it is found, we also want to check if it has not expired. If it has expired, that means that's an old data and we don't want to return it to the client. So we check if the current date is greater than the expired date, which means it has expired and it has become an old data and we need to delete it. So we call the this.delete method. So this is another method down here that we call, we pass in the key and then we return not to it. And finally, if it has not expired, we basically return the value back to the client. And lastly, we have the delete method. So the delete method basically deletes from the store. So if we need to remove a value from the cache, we basically call on the delete method and we make use of the map delete method as well to remove it from the map store. And also we have this helper method to basically convert our cache to an object whenever we want to basically retrieve it. So this is not really like a fundamental method for our cache, but this is just for like retrieving the value. So now that the cache is being set up, this is basically like CRUD. There's no update because it's not really that important for what I want to learn. So and now moving on to the usage where we have the API. So this is how it actually works in real life as well, like on the surface level, whereby you have a database, and for this instance, we have a user database. And what we want to do here is basically to retrieve users from this database, and eating the database directly is basically expensive, and that's why we need to introduce cache to make the request um, get resolved faster. And the first function that I have here is basically like a delayed function that basically delays a promise intentionally just for this demo. So it basically wraps a promise in a set timeout and then we pass in a milliseconds. And now we have the actual route. So let's imagine this is a Next.js route or any API route. And then it takes in a user ID, and we are going to make use of this user ID to basically look for the user in the user's database. And the first thing we want to do is we want to keep track of how long this request takes to reply back to the client. So for this API route, how long does it take it to get back to the client? So the first thing we now do after the start time is basically check the cache. So we have the cache here. We imported it since it is a class. So we make a new class here, and then we try to get the user ID um, from the cache. So if there is a user cache, that means like the user has already been in the cache, and then we need to return it. So we need to do a couple of things basically to get the time that the request has ended, because this is the block where it's going to end. So and then we also now derive the time that it takes by subtracting the end time from the start time, and then we basically return an object. So, and from here we can specify like the source. What is the source of the return data? Um, this is from the cache. We are getting it from the cache, and another source is getting it directly from the DB. And we now have our cache status, and our cache status is it, because we actually eat the cache, and also we return the data and we return the cache user and the time it takes to let us know how long it takes for this API to actually return. So you see why this time is very important, so that we know how long it takes when the data is in cache, and how long it takes when a data is not in cache, and then we have to go to the DB directly. And now, if the user is not in cache, what we can do is basically proceed to get it from the user DB. But intentionally, we make it resolve after 100 milliseconds, so that we add a little bit of delay, because this is going to be definitely fast. But if it is an expensive API route, we want to basically mimic it. So now we have the user DB, and then we find the user using the user ID. And if the user is found in the DB, what we want to do is basically update our cache. And to do that, we make use of the set method that we created earlier, and then we pass in the values like this. The key, which is the user ID, the value, which is the DB user, and also we have the TTL, which is time to live, how long we want this value to stay in the cache for. And then we set the value here. And then we declare the end time, which is the time that the function completed finding the user. And then we can now derive the actual time it takes by subtracting the start time from the end time. And then we can return a new object, which the source is now DB instead of cache, you can see. And now we can say our cache status is miss, because we did not actually eat the cache. So cache eat means like the response is eating the cache, but cache means that you are actually eating the DB directly. And cache means you are getting the fresh data from the DB directly, while cache eat means you are getting it from a stored data in the cache, right? So, and now we also pass the time that it takes to actually get the user from the DB, and we also have time to get it from the cashier. And now, since this is not an actual API route, we are going to make use of console.log to basically get the response of what we have here. So we are going to basically call the user API route pass user ID 1 year. So the first time, and we call it the second time again using the same user ID, and then let's see what we get, and then we now log whatever we have in our cache. So on the terminal now, we can do npx tx api.tx, and then click on enter, and we have our response. So for the first score, which is going to the DB directly because this is the first time we are actually calling the API. So you can see that the source is DB, the cache is miss. This is expected because this is the first time we are calling the API, and this is the first time we are actually looking for that user as well. So we have the data, which the ID is 1 and the name is somewhere, and it takes 102 milliseconds to complete this request for the first time. For the second time, which is from cache, we have our source from cache, then our cache status is it, and then we have our data, which is ID1, and then we have name of somewhere, which is basically the same thing, and the time that it takes is 0 milliseconds. So and now our cache record is showing that we have this value and it's going to expire here. So this actually gives me a first-hand experience on how cache actually works under the hood. I've been using cache for a very long time, even as a front-end engineer and also a back-end engineer, whichever stack I find myself doing. But then having to build one myself actually give me a very closer look into how cache actually work, right? So cache is very, very beautiful. It makes our work easier. It also on our phone, when you open an application for the first time, you will see that it takes some time to open up, but if it is already open and you click on the icon again, you see that it just pop up immediately. So this is also part of cache. And cache is also like creating a shortcut icon of an application on your phone screen or on your desktop instead of having to go to all the applications and search. So anything that makes it easier to retrieve a data or a value easily compared to going to the original source is cache. So, and it is a very beautiful technology which I'm really excited to be exploring. I want to go deeper into it as well. And yeah, so let me know if you learned something new and what is your own experience with caching, and also do you like my approach or you have a better approach, and see you in the next one. Bye bye.